So we can use tree diagrams to help us come up with theoretical probability. So let's take an example of rolling two four-sided dice like we did in the last example. But this time we're going to use a tree diagram to help us with that. So to list all of the possible outcomes using a tree diagram, with the first roll, so the first tier represents the first roll, I could roll a 1, a 2, a 3, or a 4. Now, the second tier would represent the second roll. So if I roll a 1 on the first roll, the second roll could be a 1, a 2, a 3, or a 4. And on the first roll, if it was a 2, it could be a 1, a 2, a 3, or a 4. And again, if the first roll is a 3, the second roll could be a 1, a 2, a 3, or a 4. And if the first roll was a 4, the second roll could be a 1, a 2, 3, or 4. Now something else you might want to do is then write their sums. So 1 plus 1 is 2. So I'm going to write, this is the sum down here. And then 1 plus 2 is 3. 1 plus 3 is 4. And 1 plus 4 is 5. 2 plus 1, 2 plus 2, 2 plus 3, and 2 plus 4. 3 plus 1, 3 plus 2, 3 plus 3, and 3 plus 4. And 4 plus 1, 4 plus 2, 4 plus 3, and 4 plus 4. This will help us to create our probability model. So our probability model, if we're going to use a tree diagram to help us to create the probability model, is the outcomes and as you can see, our outcomes are 2 through 8. So 2, 3, 5, 6, 7, and 8. And then right below that we want the probabilities. Well, how many total possibilities are there? Well, all you have to do is count up the last row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We already knew that from before, and 4 times 4 is 16. So how many 2's will be out of 16? And as I go through, I actually mark them off. There's only one sum of 2, so 1/16, or 1 out of 16 is our probability. As a 3, there are 2 of those, so 2/16, and we don't need to reduce it in the probability model. There's 1, 2, 3. There are 3 4's, so 3/16. 5's, there's 1, 2, 3, 4. 6's, 1, 2, 3. 7's, 1 and 2. And only one sum of 8. From there you can answer questions, what's the probability of getting a sum of 5? What's the probability of getting the sum less than 5? What's the sum of probability of getting a sum greater than 5? Things like that. But let's do another one. How about answering a 5-question true-false quiz just by randomly guessing? Or, just would it be right or wrong? So a lot of times students think that this tree diagram would look like true and false, and under each one of these, true and false, but we don't know if the right answers are true and false to the 5 questions. So this is actually incorrect. What we want to do is talk about correct and incorrect. So whether or not we guess true or false, and regardless of which answer it is, it's either going to be correct or incorrect. And again, this is the first question. Now the second question will be the next tier. And we need to give ourselves lots of room here, as much as we can. So if I guess the first one correct, the second one I guess could either be correct or incorrect. If I guess the first one incorrect, the second one could either be correct or incorrect. Now the third tier is going to be the third question. So I could either guess the third question correct or incorrect, again on all of these. And you can see I'm quickly running out of room, so I don't even know if I'm going to be able to fit 5 on here. This is the limitation to the tree diagram, is if you have a lot of levels, you know, how are you really going to get those to fit? So here's the fourth question. Correct, incorrect. And actually I have room over here, but it's on the right side that I'm starting to quickly run out of the room. And then my fifth row. Let's see, can I scoot this up? There we go. So, yeah, again, really squished. Correct, incorrect. Correct, incorrect. And then I want to talk about the end of each one of these, and how we would make our probability model for this one of being able to correctly guess 5 true-false questions correctly. Oh yeah, I am quickly running out of room here. Alright, so the probability model for this one would not be correct and incorrect. We do want our outcome, and, well, outcome and probability. This, since we're focusing on correct, we're going to go with 5 correct. You could even start with 0. Let's do it that way. So 0 correct, 1 correct, 2 correct, 3 correct, 4 correct, and all 5 correct. Well, now we've got to follow that all the way down. And this is tough. So 0 correct would represent this line right here. See, incorrect, 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 incorrect. So that would be 1 out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 1 out of 32. 1 in 30, basically a 3% chance of getting them all incorrect. Well, funny enough, maybe you've made the connection already, but that's the same probability of guessing them all correct. Correct, 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 correct. So a 1 in 32 chance of doing that as well. Now, looking for 4 correct. See, this one gets a little bit more difficult. Maybe I do a different color for this then. So 1, 2, 3, 4, and then incorrect. 1, 2, 3, incorrect, and then correct. So there's 2, 3, 4, and 5. I believe that's all of them that there are. So that's 4 correct. 5 out of 32. Does it make sense to you that just guessing 1 correct would also be the 5 and 32? And can you find them? I'll give you the answers for 2 and 3. It should be 10 and 32 for each of these. And can you find them?